Kaya Sauer of Laguna, California, and she was one of 3 essay winners. The 2 others were Austin Pritz of Walcott, Indiana, and Amanda Gutierrez of Lincoln, Nebraska. If you want to check out their essays, you can scan the QR code you see on the screen. The 3 of them beat out nearly 14,000 students who submitted essays, so you definitely want to check out the other 2, again, by scanning this QR code. So right now you're looking live at right outside of Kennedy Space Center's visitor complex. We have plenty of bleachers set out to accommodate, as you can see, a lot of guests that are hoping to see the launch today. So why don't we go in there and check back in with NASA's Leo Martin.
Hi, Megan. Yeah, this place is filling up. You can feel the excitement, people chattering, people sharing stories, people talking. And, you know, we just heard about those Artemis Moonpod essay winners who are part of the Artemis generation. Also joining me tonight from the Artemis generation, we have 2 students who were actually able to come down and visit at Kennedy Space Center to watch this launch live tonight. I'm joined here by Denham and Allison. How does it feel to be here tonight?
Really, when I first found out, I was really nervous. I didn't really know what to expect. Like, we really just looked at each other and we kind of screamed.
Yeah. Just out of excitement?
Yeah.
How did you feel?
Honestly, it was like amazing. It was surreal. Like that we have this opportunity out of so many people who applied for this. It was like outstanding.
And you guys actually got to take a tour of Kennedy Space Center a little bit earlier this week. What was something that you got to see that was just really outstanding?
I think it was the shuttle experience, like how it is when the rocket ship goes on up with people in it. It was honestly really fun doing it and learning like how they feel at the moment.
And Denham, what do you think it will be like to watch the world's most powerful rocket launch tonight from just across the river?
Well, really, I don't really know what to expect because I've never really done this before, but I feel like it would really be outstanding. I might shed a little tear, but I don't really know. Like, I'm really excited to be here, and it's amazing. Like,
it is amazing, and I don't think you're going to be the only one shedding tears tonight. Megan, we're super excited, eyes on Artemis, and we're ready to see the launch.
Thanks so much, guys. Now, Kayla, are you ready for more questions from social media? We're getting them in.
Always.
All right, let's take a look at the screen now. We have another celebrity question.
Hey, I'm Keke Palmer, and I play Izzy Hawthorne in Pixar's Lightyear, and I can't wait to see Artemis 1 launch today. How will going back to the moon pave the way to Mars?
Thank you, Keke.
Yeah, what an awesome question for tonight. I mean, the return to the moon is going to give us a chance to test all of the capabilities we need to operate on Mars. Mars is really far from home. It's going to take us 6 months just to get there, and that's with ideal planetary alignment and expected advances in propulsion technology. Then we'll spend about a year plus on the surface before it's 6 months home. And so the moon is a lot closer. We can get there in 3 days. The communications delay is a lot shorter, and so we can really test our operational concepts a lot closer to home. The moon's super far away. It's 250,000 miles, but that's way closer than Mars. So it's going to give us a chance to test all of our technologies so that we know what we need to develop in order to take that next step.
Yeah, we call it the next giant step for a reason. Mars is very, very far, like you said. All right, let's take another question from social media. Kayla, what inspired you to be an astronaut?
You know, my journey was a little bit different than some of my colleagues. I didn't grow up specifically dreaming of becoming an astronaut. I don't know what the barrier was there. I was aware of and inspired by the space program, but I never allowed myself to dream of becoming an astronaut until I had served on a submarine, actually. I think that operational experience that's so similar to what we do in the space program, if you think about it, we're sending humans to live, work, and do something of importance in a place where people aren't supposed to be, the depths of the ocean or the vacuum of space. And so I think those experiences gave me the confidence to even dream that I could become an astronaut, and then inspired me to apply in the first place.
And that doesn't deter you, again, like being in a place where, we're not supposed to be, a confined space at that.
Yeah, I think those parallels, I got a chance to meet an astronaut after serving on my submarine, Kay Heyer, who's also a Naval Academy graduate, class of 1981. And hearing about her experiences working on the space station really made me click. All of a sudden I said, the space station's a submarine in space.
Yes.
And it sounds silly, but I had never made that connection before. And once I did, I just couldn't stop dreaming about it.
Oh, that's so cool. I love that your story isn't, the typical one, as you said. Okay, I think we have time for one more question. Is Snoopy ready and excited?
Of course. I think like any crew member, Snoopy's been training for this moment. He knows what to expect in a nominal and an off-nominal launch and all the actions expected of him. So like any good crew member, he's ready to go.
And he has a suit that's been tailored to him. It's especially made for him, the way that the astronaut suits are especially made for them. So yeah, I think he's ready.
Yeah. Seeing the moon up close, he's ready to go.
So keep those questions coming. Use that hashtag Artemis and tweet or drop them in the comments wherever you're watching this broadcast. And don't forget those NASA moon snaps. Hashtag NASA moon snap for your moon-inspired content. Okay, we are now 37 minutes from the opening of our 2-hour launch window today. Let's check back in with Daryl with the launch team.
Yeah, we've had a couple of issues that the launch team has been working, and we have an update on both of those. First of all, is the leak, the liquid hydrogen leak in the replenish valve out at the mobile launcher. We understand from the launch team that that leak has not recurred. The work that happened out at the pad is that the red crew and the work that they did out there remedied the leak. That's good news. And now the liquid hydrogen tank on the core stage is back in replenish at this moment. And the upper stage of the rocket, liquid hydrogen side, is in fast fill. You can see from the graphic there that we are back up to 100% over on the liquid hydrogen side on the right hand of the screen. On the left hand of the screen, you can see we have been in stable replenish for liquid oxygen. Now, with regards to the range, they reported that they had an issue to the NASA test director with their radar sight. Later found out that that was actually a bad Ethernet switch that was cutting out and not providing them the data. The range reported that they will swap out that bad switch, and they're currently working on that. They advised at the time, about a half hour ago, that it would take them about 70 minutes, or about 25 minutes into that work. They did just recently update the NASA test director to say that it's going to take them a little bit longer because they're going to need to re-verify this Ethernet equipment once they have it installed. Again, that work is ongoing, but at the moment, if we were launching right now, the range is no-go as a result of that bad Ethernet switch. The Dolly Loop file, which helps steer the Space Launch System through the upper atmosphere, has been uploaded to the rocket, and so we're good to go there in terms of other configurations that are ongoing. But we are continuing to monitor communications of the launch team about holding to the top of the window, currently slated for 1:04 a.m. Eastern Time. But we do have 2 hours, and we have yet to see whether or not the launch team is going to be able to make enough adjustments in order to hit the top of that window. No slip yet, but we're monitoring their work, and we'll give you an update when we have it. Back to you, Megan.
Thank you, Daryl. Really great news about that leak. Kayla and I actually said, wow, that's really great news. So we'll wait on your next update. Let's go back live now to Kennedy Space Center's visitor complex, where we have NASA's Dan Hewitt inside there with our new moon board. Dan, let's focus in on Orion now. It has 3 main elements, right?
That's right, Megan. And Orion is the spacecraft that's going to be carrying our Artemis astronauts off of planet Earth and then returning them home. As you said, 3 major components, so we'll jump in here at the top with the first one, the launch abort system. This is a critical safety feature on Orion, designed to pull the capsule away from the SLS stack in the event of an emergency on the pad or the way uphill. And it does that using 3 solid rocket motors. The first one, the abort motor, can fire within milliseconds of automatically detecting an issue, pulling the capsule away to a safe distance. After that, the attitude adjustment motor. This one will fire. We can cancel out any rates, put us into a nice stable glide before we get ready to fire the jettison motor. This is the one that will actually take the launch abort system off of Orion, allowing it to then deploy parachutes and parachute down to safety. I will note the jettison motor, the only one that fires no matter what on a normal mission. It's going to fire once we're high enough in the atmosphere. And for Artemis 1, that is the only motor on this that is active. The attitude and abort motors are inert for Artemis 1. And that's all focused on protecting this, the Orion crew module. This is where you have your astronauts physically inside. In the capsule, you have everything you need to keep a crew safe, happy, healthy, thriving in deep space. You have a pressurized environment, seats, crew displays, toilet, everything that you need. On the outside, couple of critical features. On the bottom, the heat shield. Remember, this is goal number one for this mission, is testing that heat shield. It's an ablative structure made to survive that fiery re-entry at the end of a mission. Along the outside, you see these small gray circles. Those are reaction control system thrusters. Orion can use that at the very end to control the yaw, pitch, and roll as it's hurtling through the atmosphere. We have windows. You need windows to look outside. 2 on the front, 2 on the sides, 1 in the side hatch, 1 up top in the very top docking hatch. Those are different layers of glass and acrylics for pressure and thermal control. We have a docking system, an uprighting system, parachutes, all for the very end of the mission. Third and final piece, down here at the bottom, the European Service Module. This has all of the propulsion assets for after SLS has done its job. Starting on the bottom, the large orbital maneuvering is the one that's providing the most thrust for all of those key maneuvers around the moon. 8 auxiliary thrusters also around the aft to the bottom part of the service module to provide some additional push as well. And then 24 of these smaller reaction control system thrusters. They can be used for attitude control, which way you're pointing, as well as small translational maneuvers moving side to side. If we flip the vehicle up, we see 4 solar arrays, each one 24 feet in length, all together generating 11 kilowatts of electrical power for Orion systems. Inside the service module, you have tanks for things like the thermal control system, potable water when we have a crew on board, and also pressurized oxygen and nitrogen for an atmosphere, which gets fed through this umbilical here to the crew module along with electrical lines. That's also what's going to separate us at the very end of the mission. So that's Orion. It's going to be making its first flight around the moon on Artemis 1. Can't wait to see it, taking those selfies around our lunar neighbor. Send it back over to you, Megan.
Thanks, Dan. That last component Dan talked about, the European Service Module provided by the European Space Agency. Let's go to Jasmine for that.
Thank you, Megan. We are back in Firing Room 2 at the Launch Control Center, and joining us now is Philippe Delou, ESA's program manager for the Orion European Service Module. You have quite the title there, a big title for a big job, I'm sure. We are very glad to have you here, and we understand that the European Service Module is powering Orion that's going to send humanity farther than ever before. Philippe, how is it getting us there?
Yeah, thank you. Good evening, everyone. So yes, the service module accommodates the propulsion system that contains among the tanks and the pressurization of the system the engine. All the engines, 33 engines in total, among which the main engine, which is going to perform the burns to put Orion into the moon orbit and then back on the trajectory to return to Earth. The other engines are used for attitude correction during, attitude control and trajectory correction during the travel to the moon. In addition to the propulsion system, the service module generates the power and distributes the electricity to the crew module and the service module equipment so that they can operate. And the third function is the thermal control of the system, the service module.
Moon sending human beings as part of the Artemis program. What are we hoping to learn that's new?
Yeah, so we're going to an entirely different part of the moon for Artemis, right? During Apollo, we kind of landed almost in the same place, like 6 times, right? In the sort of central near side of the moon. But for Artemis, we're going to go explore a new part of the moon. We're going to go to the South Pole, which is some of the oldest rocks on the moon. It's the part of the original crust of the moon. And there's places there that are permanently shadowed, where we think that water and other molecules sort of get trapped, and we really want to understand what those are, and so that we can use them for both science and for as a resource.
Sarah, we're also planning to land a rover at the South Pole of the Moon in late 2024. Can you tell us about that?
Yeah, absolutely. The Viper rover, the Volatiles Investigating Polar Exploration Rover, is going to go land near the South Pole, and it's actually going to explore some of these, a very small amount. But if you look at what we brought back from Apollo, it's a probably maybe thousands of scientists have been able to study over the years and over generations, and that's a lot of brain power to put behind those samples.
So again, that's how Artemis and Apollo are different. Now we're utilizing machines and people.
That's right.
To
Work
hopefully
together.
advance. Yeah.
That's right.
Perfect. Sarah, thank you so much for your time.
Thanks for having me.
So in honor of our destination, the moon, we asked you all to create moon-inspired content and share them with us using the hashtag NASA MoonSnap. We got so many wonderful submissions, so why don't we check them out now? That was a really cool look at all the different kinds of creations, recipes, and also art, and it was great to see what people submitted.
Yeah, it's awesome to see the creativity out there and how people are engaging with this mission in so many different ways.
Yeah. So I know that you didn't submit it yet, but you did create a moon snap, so to say. So why don't we take a look at that picture?
Yeah, this is one of my favorite pictures of the moon that I was able to take from orbit. I think for me, it kind of reminds me of that iconic picture of moonrise or Earthrise from the moon from Apollo. And it's kind of that in reverse. I think there's something about seeing the moon from orbit around the Earth that makes it seem a little bit easier to imagine what it'd be like to have that view from the moon looking back at our home planet.
Yeah, you should definitely submit that because that's an amazing photo. Did you take that yourself?
Yeah, out of the cupola window aboard the space station.
Wow, the resolution's great.
The cameras we have up there are incredible.
Yeah.
It's awesome.
So I haven't taken a moon snap, so I have nothing to submit. So how do you feel about creating a moon snap with me?
Let's do it.
All right, well, take that, if you don't mind lifting it up, and we're just going to snap a photo here. Oh, lighting. Perfect. So I just created a moon snap. I love it. I'm going to share it. And again, this is just to encourage people to really get involved in this mission. So we will continue to collect and share those photos. So again, if you have a NASA moon snap, just use that hashtag. Okay, Artemis 1 comes amid a very busy year and exciting year at NASA. Some of the highlights include 2 more commercial crew launches with SpaceX, Crew 4 in April, and then Crew 5 last month. In May, NASA and Boeing flew OFT-2, the second uncrewed flight test of the Starliner capsule. The goal is to certify the capsule for regular flights to the International Space Station after a crewed flight test next year. In July, we released the first images captured by our James Webb Telescope, and oh my, those are really beautiful, fascinating photos, and they're going to really help us answer some of astronomy's biggest questions about how our universe began. And then in September, we intentionally slammed the DART spacecraft into asteroid Dimorphos. Boom, look at that. And we successfully changed its course. The asteroid wasn't headed for Earth, but the test was to show we could defend our planet if needed. And recently, 2 other missions that benefit the Artemis program. Last week, we tested a new inflatable heat shield that could help us eventually land humans on Mars. And just 2 days ago, Capstone arrived at its intended orbit around the moon. The small satellite launched from New Zealand in June and will now test a unique lunar orbit for a future space station there.
Artemis 1 heralds a new era in the history of human spaceflight. It marks a pivotal next step in humanity's return to the moon, ushering in a new generation of astronauts, technology, and research. This critical flight test sets the course for a bright future at the moon. It represents our ability to safely send Artemis astronauts and critical hardware to lunar orbit. Humanity will experience Artemis in different ways than we did Apollo. We will explore new areas of the moon with 21st century materials, technologies, systems, and operations. Gateway will be humanity's first space station to orbit the moon, built with next-generation technology. Gateway will not only provide a deep space outpost for future lunar expeditions, it will also serve as a station for landers, experiments, and supplies. Starting with the core power and habitation elements, Gateway will grow with increasing capability as international partners contribute new habitat and refueling modules, observation windows, external robotics, and more. Gateway will enable longer stays and more science to be conducted on and around the moon than ever before. And one day, it will help set the stage for missions to Mars. A highly skilled, diverse core of astronauts will be selected for Artemis missions, including the first woman and first person of color to step foot on the moon. Aboard Gateway, the crew will conduct exciting research from their unique deep space vantage point. Gateway will also be a transfer station for astronauts to board innovative human landing systems that will ferry them to and from the lunar surface for exciting scientific expeditions near the South Pole. Once on the moon, Artemis astronauts will use expertise in fields like biology and geology to conduct groundbreaking research in modern spacesuits using advanced tools. They will drive new rovers to investigate the lunar terrain and unlock some of the greatest mysteries of our solar system. Artemis 1 cements our capability to send astronauts and cargo to the moon for years to come. We're going back to the moon. We are Artemis.
As we approach the opening of our 2-hour launch window, we have a special musical performance for you. America the Beautiful, played in honor of the flight test by the Philadelphia Orchestra and Yo-Yo Ma.
망했다. 아, 왜 이렇게 안 되지 이게? 자, 이제 뱃살 14분 남았어요. 저거 좀 느릴 거예요, 아마.
truly beautiful performance. It really has me feeling quite emotional right now.
Yeah, perfect tribute for tonight's launch.
You know, it's just it gives me a sense of pride, really, to just remember that our country continues to lead our nation in space exploration. So, and as such, the White House is closely watching this historic launch. Earlier this year, Vice President Kamala Harris came down to Kennedy Space Center and met with NASA leadership as well as astronauts. She also toured our facilities where teams are working on hardware for future Artemis missions. Before leaving, she signed a piece of the Orion spacecraft that will fly on Artemis 3. She's doing it right there, which will return astronauts to the lunar surface. Okay, Kayla, time for more social questions. So let's take the first one. You know now the drill. It's going to be a celebrity question, so let's take that.
Hey guys, I'm Jack Black and I'm super excited for the Artemis 1 launch today. I was part of a little movie called Apollo 10.5, A Space-Age Childhood, and I have a few burning queries. Question the first. How is Artemis different than Apollo?
Artemis is different than Apollo because we're returning to the moon, but this time we're going to stay. So rather than a short visit where we can do some amazing science, but it was pretty limited by these short visits, kind of a small area of the moon, we're going to the South Pole and we're going to learn how to live there long term. So we're going to be building habitats, we're going to have rovers, we're going to have all of this infrastructure on the moon supporting scientific discovery, but also that next big step to Mars.
I love seeing celebrities also take part and ask questions because it really shows that this is something that's captivating a lot of people. So that was really fun to see Jack Black. Also, query the first. That was funny. All right, let's go to the second question. How does it feel in space?
Being in space is amazing. I mean, for us launching to orbit around the Earth and then go to the space station where I just was for 6 months, we're in an apparent microgravity environment. So for us, it feels like we're weightless, like we're floating. So you have to relearn how to live and work in that space. But once you get used to it, it's a lot of fun.
Yeah, we were just talking, Jessica Watkins, another NASA astronaut, was just here. And she was saying that actually when you came back on Earth, that was an adjustment as well because you got so used to living on the space station.
Yeah, the transition home was actually a lot harder for me than the transition up there because our vestibular systems kind of remap. We start ignoring all the sensors in our inner ear that tell us how our bodies are moving because the space environment is so strange, but we really need that on Earth to balance and control our bodies.
Sure.
So when we get back, it takes a couple of days before we feel comfortable again.
Really interesting. Thanks so much for those. Okay, so we are 10 minutes until the opening of our 2-hour launch window today. So why don't we head back over to Daryl. Daryl, tell us what's happening now.
Yeah, Megan, we actually have about 10 minutes before we go into a half-hour hold. That half-hour hold is part of the L clock, and what you see on your monitor right now, I believe, is the T clock. So in about 10 minutes, we'll hold for a half hour, and currently the launch team is trying to evaluate how much of a delay may result from some issues that we've been facing over the past hour. Just to recap those, we had a leak in a replenish valve on the mobile launcher that feeds into liquid hydrogen core stage tank. That's been resolved. The leak has been fixed, and we're moving forward. Currently, the upper stage of the rocket for liquid hydrogen is roughly 78% at the moment. So that is tracking. Progress continues there. The core stage has been topped off. And now both liquid oxygen and liquid hydrogen are 100%, along with the upper stage of the liquid hydrogen side of the equation. So we're just waiting on the complete tanking of the upper stage liquid hydrogen. Now, with regards to the range issue that we had, we just got an update from the range, the 45th Space Wing. Officer reporting in to the NASA test director that the Ethernet switch has been replaced. This problematic switch took down their ability to see radar from one of their assets, which is key in getting acquisition and signal for the flight termination system if it were to be needed. Of course, this is a critical system that has to be tested before we can launch. So at the moment, we're looking still at a 1:04 a.m. Eastern time
시간이 왜 2시
launch.
반인데
But it is
2시
pretty
반도 안
clear
됐는데
from
왜
the
발사가 안
work
되냐.
that is ahead that it looks like we're going to slip into that window. How much exactly, we don't have an accurate calculation from the launch team as of right now. But of course, we're anticipating that. So for the moment, you see on your clock now, we are in the T-minus 10-minute hold. We just entered that. And now, roughly, we're looking at 28 minutes to resume terminal count. The launch team will assess what work needs to be done, how that syncs up with the range getting back online
원래 시간이 원래 3시
with their
6분이에요.
equipment,
아직 한국 시간
and then
3시
we should have a
6분이니까
new T0 for you soon.
지금
That's the latest from
전체적인 그
firing
시스템을
room 1
보겠다는
here at the
얘기죠.
Kennedy Space Center. Megan, back to you.
So things are obviously still very dynamic. We're going to come back to Daryl as much as possible. Now, to understand where we are going, we have to know where we have been. To do that, we spoke to some of the special few who walked on the moon and those who sent them.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
It's been 50 years since we've been to the moon, and we've got a great program called Artemis. We're going back. The Apollo program was a test for the American people that you can do what you set out to do. All it took was turning to it and making it happen.
We are go for a mission to the moon at this time.
Engines on 5, 4, 3, 2, all engines running. Launch commit, liftoff. We have liftoff 49 minutes past the hour.
I think the characteristic that I remember most of the Saturn V was the noise. The noise was enormous and it was almost impossible to communicate.
We're go, think high, we're go. Tranquility Base here. The Eagle has landed.
The landing to me was a great celebration. The nation was almost euphoric.
That's one small step for man, one giant leap for mankind.
There are so many things that we can eventually learn about our universe and the spacecraft that we use exploring.
We are a nation of explorers. During Apollo, we were on national TV literally every day because we were doing something visible that Americans could see and they could feel and say, look what we are doing. And I believe Artemis is going to come up and say, look what we are capable of and what we are doing now.
Artemis will stand on the shoulders of Apollo. They're going to have the eyes of the world on them when they start down this trail.
The science of a space flight is one that will continue to inspire. Going to the moon generates technology, more communications, more computer technology, more sophistication in manufacturing that help us in everyday life.
We have a generation that is ready, a generation with that technology, a generation with the education. Artemis represents the future in space. It is our next big step, and it is time to take it.
If you're just joining us, welcome to NASA's Kennedy Space Center, where we are showing you a live look of another visitor center. This is the U.S. Space and Rocket Center. Wow, take a look at all of those people who are there hoping to watch the launch today. You know, this is the visitor center for the Marshall Space Flight Center in Huntsville, Alabama. That center played a crucial role in contributing to the Artemis program. So I'm not surprised that there are a bunch of people there watching. All right, so now we're going to go back to Leah Martin over at Banana Creek. Again, that's right outside of our visitor center, and she's with some other folks who came out to watch today's launch.
Yeah, you know, Megan, we talked about this being America's rocket, right? Every state in the United States has contributed to this rocket, so it should be no surprise that we have people from all over the country joining us here tonight. I'm actually joined by some friends of ours who are joining us from Georgia and Utah. What does it mean to be here tonight to see tonight's launch?
I think it's amazing. I know that tons of people from all over the United States have helped build the rockets and are here tonight, so it's awesome to know that we all have a little bit of personal ties to the rocket.
And go ahead.
No, I'm just excited to be here because I've been a fan of space travel and going to the moon and back, and I'm glad to see it's happening again later in life.
And you were actually telling me a little bit earlier that you grew up in the Apollo era in those years following those first launches, and now here, how does it feel to be watching the sister program launch and seeing at the beginning?
Look at the goosebumps. That tells it all right here. I'm totally thrilled to be here.
Now, and you were actually telling me that you have a personal connection to this rocket as well. You know some people who have worked on it. What do you think it feels like being here? How does it feel for you to see something that's the culmination of so many years of hard work?
Yeah, I think it's crazy when you think about how long it takes to build it and stuff. Like, I wasn't even born last time people tried to get to the moon. So it's awesome. I think it's so exciting, and I cannot wait.
And we have a ton of people who are working tonight still on console. We just wanted to tell them words of encouragement. What more do you have to say?
Oh, I hope it goes tonight.
Megan, back to you.
Go Artemis.
Woo!
Go Artemis. Yes, I love that. And again, I just love these drone shots that we're showing of all the people who are here ready, hoping, anticipating launch today. So now let's head back over to Dan. So Dan is in the Apollo Saturn V Center, which is right next to this crowd that you're seeing here. He's inside there, and he's going to tell us more about SLS using an interactive state-of-the-art tool we're calling the Moonboard.
That's right, Megan, and everybody, welcome back to the Moonboard. So just to recap, SLS out on the pad, on the mobile launcher. Daryl's been walking you through all of the tanking, all of the preparation. We had that hydrogen leak that was in the base of the mobile service structure here. That's been remedied. We haven't had any issue with those tail umbilicals that we were tracking so closely back in August and September. So everything looking really good with SLS. Just to recap, most powerful rocket we have ever built. It's propelled by 2 solid rocket boosters and 4 engines on this core stage. Now these solid rocket boosters are going to be firing for the first roughly 2 minutes of the flight, a little more than 2 minutes. And we call them solids because of the type of propellant in there. If you forgot it already, it's aluminum powder, ammonium perchlorate, and polybutadiene acrylonitrile. It's a binding agent that's inside. Solid propellants are extremely stable. They're very reliable. But once you ignite them, they're going to keep burning. You can't really throttle them up and down like you can with liquid-fueled engines. You can throttle just based off of the distribution. So you basically put more propellant in some areas and less in others as you're trying to really throttle the rocket down, which we do as we go through things like max Q, maximum dynamic pressure. And just a reminder, as these things are firing, they can steer, they can gimbal. The bottom part here, gimbal just means you can really direct, and they're providing 90% of the steering as SLS is making the flight uphill, and more than 75% of the thrust with those 2 firing at the same time. And again, they're attached to this. This is the core stage, 212 feet tall, the largest single stage we've ever constructed. It's been through the green run test, a lot of preparation for this flight today, and it is propelled by these 4 RS-25 engines. Now these are liquid fueled rocket engines, so you have a fuel and an oxidizer, and one of the great things about liquid fuel is you can throttle them in real time. You could kind of like the gas in your car, you can go faster or a little bit slower. So these throttle up to 104% of their rated thrust at the time of liftoff. We throttle them down as we go through max Q, so the maximum amount of pressure on SLS on the way uphill, and then throttle them back up until they've consumed all of their propellants. And they're consuming that propellant at more than 1,500 gallons a second. That is just an astronomical amount of fuel that's running through these engines to produce that thrust. Each of these up to 500,000 pounds each during their operation. And of all the different components, we've got this engine block section down here. You have all of the associated plumbing, everything to feed those propellants down to these engines. You also have these 2 attachment points here, and that's where we actually tank the SLS rocket. So a lot of focus on those in the previous attempts. They've cooperated spectacularly so far today. today, and we've been able to fully tank this core stage. And a reminder, you have a fuel, about 500,000 gallons right here of liquid hydrogen, and then an oxidizer. You need those two together, and then an ignition source. That's what gives you your reaction, your thrust, your basically controlled explosion that then comes out of those rocket engines. So fully tanked, these are cryogenic fuels, hundreds of degrees below zero, so we've got a spray-on insulation across the entire vehicle. As it's sitting out there in the Florida air, it's a little bit warm tonight, but we need to keep those hundreds of degrees below zero. It takes a lot of energy to do that, so the less you have to use to keep them cold, the better, which is why we have that insulation. So we're going to be seeing SLS take flight for the first time tonight as we clear all of those final issues. Again, this is going to be one heck of a show when this thing launches into the night sky. So with that, send it back over to you, Megan.
If you're just joining us, welcome to NASA's Kennedy Space Center for live launch coverage of Artemis 1. I'm NASA's Megan Cruz, and this is NASA astronaut Kayla Barron. It's been great having you these past 2 hours.
It's been so awesome to be here for this historic launch tonight.
So right now we are awaiting a new T0. The launch team had to work through some issues, and they're doing a great job at working through those issues. So now we're just waiting to see a new T0, since we had been aiming for the top of the launch window, which opened does open at 1:04 a.m. Eastern Time. Now, today is a big deal. Apollo 17 in 1972 was the last time humans stepped foot on the moon. That the rocket you see right there behind us, illuminated in the darkness there, is the first step back towards getting us to the moon. Now, Artemis 1 is the first integrated flight test of NASA's deep space exploration systems. That's the ground systems here at Kennedy Space Center, the Space Launch System, or SLS rocket, and the Orion spacecraft. We will send an uncrewed Orion spacecraft farther beyond the moon than any of the Apollo missions before it. For Artemis 2, Orion will have astronauts on board as it orbits the moon. Then future Artemis missions will land the first woman and first person of color on the surface of the moon. So Kayla, why do we want to go back to the moon?
The moon's a super interesting place to study. It can tell us a lot about the Earth, its own formation, but also more about our solar system. And we also want to return, this time in an international partnership, for a permanent presence on the lunar surface that'll teach us everything we need to know to travel onto Mars.
And what about for you? I mean, you have the possibility of maybe being selected for those future missions, because the Artemis program can choose from any of you guys, any of the NASA astronauts.
It's a crazy time to be a NASA astronaut, and even imagine that that could be real. I think we're all just honored to be a part of the team that's doing this. We're just a small representation of all of the amazing human beings around the world that it takes to do something as audacious as returning to the moon, learning what we need to go onto Mars. So we're just all excited to support the program in any way we can. But of course, a ride to the moon would be incredible. So I think we're all just dreaming about those moonwalks.
Now, since Artemis 1 is setting the stage for those future crewed missions, is there anything in particular about this 26-day mission that you will be watching? Is it re-entry?
Yeah, you know, we've mentioned that a few times throughout the broadcast tonight. The re-entry is a really important part of the flight, of course, and the heat shield, we're interested in seeing how it performs in real life. We tested it on the ground, but Orion's going to be coming in faster and hotter than any human-rated spacecraft in history. And so we really want to see how the heat shield performs and make sure all the systems can keep the crew safe for that dynamic event.
Yeah, we'll all be watching for that too. It's not just about the launch, a 26-day mission, as we said, so we'll be keeping watch over the entire mission. Our workforce now is very different from what it was during the Apollo era. When Apollo 11 launched, there was only one female engineer in the firing room. Today's launch of Artemis 1 is led by NASA's first ever female launch director. Take a look at how she and other women across NASA are shattering glass ceilings.
When I was a little girl, I wanted to be an astronaut, a scientist, a doctor, a fighter pilot. When I was a little girl, I wanted to grow up to be strong and independent.
When we were asked to draw a picture of what we wanted to be when we grew up, I drew an astronaut standing on the surface of the moon.
All I thought about was when I was going to get to NASA.
It's a huge honor to be NASA's first female launch director. To be the launch director for Artemis NASA has so many wonderful women pioneers, so many heroes to me.
Some of the most amazing women in my eyes are people like Katherine Johnson and the other women that you've seen in Hidden Figures.
Sometimes it's difficult to believe that I'm on this side now wearing this blue flight suit with all of the other astronauts, representing this iconic image that had so inspired and excited me my entire life.
Being of South Asian heritage, Kalpana Chawla was just such a big thing for me growing up.
I've always looked up to Sally Ride and Mae Jemison, who really laid the foundation to allow people like me to be in the position that I am now.
All of these women were pushing those boundaries and breaking those glass ceilings. Now, of course, there are some fantastic women in leadership positions that inspire me every day.
So much has changed since the Apollo program. During the Apollo 11 launch, we had one woman, one out of 400 engineers in the room. And I look at our team today, it's much more a reflection of the world that we live in.
A big piece of why it's so important to have women and diverse backgrounds, because it allows us to bring everybody along with us on this journey.
It doesn't really matter what you look like. If you've got the brains and you have the knowledge, we need you at the table.
We are at such an exciting time in human spaceflight right now, and Artemis is such a huge part of that.
We haven't been to the moon in many, many years. We have a lot of younger generation folks that have never seen that happen.
We will understand so much more about the moon, about the Earth, about our solar system. We're going to stay. And to me, that's an amazing idea. The moon is going to be the blueprint for how we go to Mars and out into the solar system and maybe beyond. It is incredibly exciting to be part of this Artemis team. It still feels pretty surreal to think that I might one day walk on the moon. To see a woman and a person of color on the surface of the moon, to be able to say that space is for everyone and that we go to space to make life better here on Earth for everyone. I know that tears will be in my eyes.
33개 중에서 지금 14개
My message to women and girls out there is to find your passion, whatever that is.
Don't let anyone tell you what you can do or can't do. Only you can realize your dreams.
스페이스X 창립 역사상 가장 강력한 엔진을 점화시키는 게 어제 심지어는 예전에 그
I just actually love that I don't
1960년대,
feel like a
70년대를
woman at
호령했던
NASA.
그
I
스테픈
just
V
feel like a
로켓
person
있잖아요. 그
at
로켓의
NASA. The women of
수력에
NASA
거의
are
근접했다.
Artemis,
그래서 앞으로
and we
아마
make a
그
difference
스테픈 V
every day.
로켓의
I am
거의
NASA's
그
spacewalk
수월해가
office hardware
넘어가지고
manager. I'm the
가장
program
강력한
scientist
엔진을
for space
스타쉽이 아마
biology.
할
I'm the
겁니다.
director of
그
NASA's
스타쉽도
Johnson Space
지금
I am Artemis.
I am Artemis.
스타쉽 뭐
아르테미스 데스. Yo soy Artemis.
아르테미스
Ana.
오늘
Je
스타쉽
suis
얘기
Ich bin
들었는데
Artemis.
스타쉽 이후 발사를 아마
I
6개월 안에
am
할 거라고
Artemis.
예상을 하고 있는데 글쎄요 지금
I just
진짜
love the way
상황으로
that that
봐서는 좀
video
시간이
ends
더
with
걸리지
you and
않을까
all these
생각도
other
들어요.
women saying, I am Artemis.
일단은
What do you
그
think?
상부 단계에
Why is
스타쉽은
it so
6개
powerful to just
엔진하고
hear
2개
those
엔진 있는데
three
그거는
words,
이제
I am
점화
Artemis? Why does that
연테스트까지
resonate so
끝났어요.
much?
그럼 이제 이거는 이제
I
거의
think it just
끝나가는데
represents how far we've
문제는
come
이제 그
since the Apollo era
슈퍼헤비
and
부스터
how we
있잖아요.
take
그게 지금
advantage
안
of
되고
the
있으니까
incredible diversity
그거
our country has to
테스트하고 계속
offer.
이제
Having seats at
33개
the table for
엔진을
everyone,
한꺼번에
space is for
점화시키는
everyone. You heard that a few times in the video,
그게
and I think we're
끝나야지
proving that
아마
out every single day
가능하지
in our work,
않을까?
not just at NASA but with
발사가
our
가능하지 않을까
international
뭐
partners.
생각도 듭니다.
I think it's so important to our ability to
여기
succeed
솔직히
on
이제
these really
SLS
complex
얘기를 많이
missions.
하지만은
I thought
솔직히
that was a
이제
very powerful
나사가
video,
그
and
오랜만에
I'm
달로
glad
가는
that people got
탐사
that
우주선을
message,
만들
young
그
girls in
로켓을
particular.
만들었잖아요.
Another person who you saw in
사실
that
문제가
video
엄청나게 많아요.
is Pam Melroy.
그래서 이
She's
로켓
a former astronaut and
이쪽
NASA's
그 잘 아시는
deputy
분들은
administrator.
오히려 그
So why don't we
제임스
head over to
우즈만
Jasmine
것보다
Hopkins
더
who's
많이
there
많은
with
게
her now.
스타쉽이라고 활동도니까요. 어쨌든 간에 뭐 지금까지 고생했으니까 발산을 해야죠. 그러니까 지금 T-10분이니까 10분이 아마 저분은 지금 보이시는 분은 네, 지금 멜로이 그 나사 부국장님이세요.
Yeah, I loved watching that video. Just inspires me. So many of those women are my friends, but also they're just such fantastic engineers and scientists and just so many roles at the agency.
저분은 뭐 그렇게 많이 보이는 분 아니시죠? 전직 우주 비행사 출신이십니다.
Men and women, and so our teams are stronger. I think when we have that balance and that diversity. So that was exciting. But For me, I was a part of the Apollo generation, and I was very inspired by, Neil Armstrong and Buzz Aldrin and Mike Collins on Apollo 11 and all the Apollo astronauts. I just cannot even imagine
영원 사케
the
영상인데
inspiration, though,
항상
for
그
a little
720
girl.
보니까 너무
It never
화질이 옛날 거야.
occurred to me that
웬일이야.
there- I mean, I wanted to be an astronaut, but of course there were no women
하긴
astronauts.
돈이
then.
그게 다
I
돈이니까.
think what's going to happen now with the
쉽진
Artemis generation is that first woman and the first person of color is just going to have a huge impact on the next generation.
Right, we are just watching with bated breath, and I know that it's going to mean so much to little kids to look up to them. And we understand, too, this is a huge, I mean, when we launch Artemis, it's going to be a global accomplishment. We have the Artemis Accords, which are helping us make sure we explore peacefully. Can you tell us more about those?
Yeah, it's really important, actually, especially because unlike an Apollo where it was actually just a few countries that had the capability to go to space.
새로운 그
now those
카운트다운 시간이
capabilities are proliferating
T-1이
throughout the world.
한국도 있죠.
And
아르테미스
so what we do
측정해가지고
with the rocket is really important.
T-1
How we go
그
is just as
T-1
important. And how we
제로
go is as teams
타임이
and with our partners and with a sense of the responsibility that we have as we go out into the solar system to do it peacefully for scientific purposes and responsibly.
Right, Pam, you have a great sense of teamwork, and this is definitely not our first time. There's a lot of things that go into testing out a first-time vehicle. There's actually dynamic activity going on right now. So how does this first flight test of SLS compare to other first times, with Shuttle or with Saturn V before that?
Well, I can do even better as a test pilot, right? So there's a history there. In fact, the amazing thing about this is so first flight of a first aircraft, you actually taxi it out to the end of the runway and then run down the runway and come back and check all the data.
1시 4분이니까 거기서 플러스 한 2시간도 가능하니까
This is a little bit like taking off and going to fly a full mission on the very first flight of an aircraft. And so everything has to be right. So this compares it's very similar to the experiences that all new rocket developments have, where, it's not just about learning the hardware, that's a big piece of it, but it's also about gelling that team together and your procedures and how you're going to deal with issues that come up, because they will come up. They always come up.
Exactly. And you have that experience as a test pilot, but also as a former astronaut. In that video, we saw you getting your induction into the Astronaut Hall of Fame, which is pretty cool. So what is your perspective, or what advice do you have for the Artemis astronauts, those ones that are going to maybe set foot on the moon?
Oh, well, they don't need my advice. I'd love to elbow them out of the way and go to the moon, too. But they are fantastic. I mean, I'm so proud of all of our astronauts. I was just talking to Jessica Watkins, who just came back on Crew 4. This generation is prepared, ready, and excited. And I think they're really excited that we're putting science front and center in the Artemis program, too. We're going to learn so much about the solar system from the moon and even about the Earth. And so I think the astronauts are really excited about doing that hands-on science, and they are ready to go.
Right, I know they're ready to go, and maybe you are as well. But Artemis 1 is just the beginning. Then we have Artemis 2 and on. We're learning so much. What do you think about this just forward movement that we're making right now?
Well, it's really important. This is the Artemis campaign is actually part of a multi-decade effort that we're doing right now, which is really with the goal of creating a blueprint for how we're going to explore with humans and do science throughout the solar system. So we're going to learn through the Artemis campaign on the moon, and then we're going to go demonstrate it on Mars, and then the next destination, who knows where.
Right. I mean, we're going so much further than we ever have before. Pam Melroy, thank you so much for joining us.
Thank you. Go Artemis.
Of course, go Artemis. Megan, back to you.
Thank you both for that interview. Now, teams over at NASA's Johnson Space Center are also monitoring today's launch attempt. So why don't we go back over there with Leah to tell us what's going on over there.
Thanks, Megan. And you're right. Teams here in Mission Control Houston continue to monitor today's events. Again, they will really kick into action once we have liftoff, and they'll remain on console all the way through splashdown. But quickly, I have to show you something, a little show and tell. It makes me feel like the coolest kid. In school, I've got a moon rock here. I hope you can get a good shot of it. It is from Apollo 15, 1971. And when it was brought back to Earth, it was part of a larger rock. In total, it was 21 pounds. This is, of course, a smaller section of that. But we're looking forward to the Artemis program and being able to go back to the moon so that we can continue to gather these kinds of samples. But this time at the lunar South Pole. We've never been there, and we've never brought samples back from that area. So we're really excited to see what might differ in those samples and the ones that we have here. Now, of course, we've got a whole laboratory of scientists that are able to study all of those samples. We just opened some up for the first time earlier this year so that we're able to test with new technology everything that we can learn about these samples that we brought back now 50 years ago. So hopefully within the next few years we're bringing some new ones back to use that same experimental process on and tell us a little bit more about the moon. But just had to show this off. Apollo 15 moon rock. We're looking forward to having some Artemis ones here at Johnson Space Center. With that, I will send it back to you at KSC.
You were a cool kid before you even had the moon rock, so. But now you're even a cooler kid. Now, the name Artemis was chosen because in Greek mythology, she's the twin sister of Apollo. NASA's Leo Martin is over at the nearby Kennedy Space Center Visitor Complex, where thousands have gathered to watch today's launch attempt.
Hi, Megan. I'm actually joined here tonight by a very special group of guests here from Stennis visiting Kennedy Space Center. Why don't you tell me, Ryan, what it is that ties you to tonight's launch?
So we were lucky and privileged enough to be able to test the core stage of the SLS rocket that's going to launch today. We got to Green Run, which is a full duration hot fire. It's a very historic time for us at Stennis. It was so exciting to be a part of. It was 7 years of hard work by a lot of really great people.
And Jack, sorry about
just so excited to be here to see it.
And Jack, you were actually telling me that you know firsthand, how much work has gone into tonight's launch. What does it feel like to be here tonight, seeing the rocket fully integrated on the pad, ready to go?
Man, I'm just incredibly grateful to be a part of this history and just really excited to see this thing launch.
And Barry, you were telling me that you know also firsthand, the adversity that these teams have overcome to be here tonight. Do you have a word of encouragement, anything that you'd like to say to the teams all across the United States right now, both at Kennedy and at JSC, who are just sitting in these seats ready to get the rocket launched tonight?
Sure, persevere. I mean, it's hard work, but it's so well worth it. We spent many hours doing the testing, trying to get ready for this moment, and I think we've forward that information to those guys, and we also give them the encouragement to continue on, so we know they can do it.
Thanks so much, Barry, and I think it would be great if just on the count of three, we can give them a great big go Artemis. 1, 2, 3.
Go Artemis!
Back to you, Megan.
That was amazing. And that's just, people who were actually able to come here to Florida. There's many people who are joining us from around the world who couldn't obviously make the trip out here. So let's take a look at some of those watch parties there. Here's Space Center Houston. It's the visitor center over for Johnson Space Center in Houston. And you can see a lot of people there after hours because that visitor center is closed right now. People are waving. I love it. Wow, look at that, whatever that is.
That's
it's
awesome.
amazing.
I don't think I've ever noticed that when I'm at Space Center Houston. Maybe it's new.
I know. But yeah, just look at that crowd. It's really fun to see, again, all these people who are captivated, young and old, by today's launch attempt and the beginning of the Artemis program. I know that they're probably looking at the clock and wondering when we might see the launch today. So lovely to see all those people.
And there's the Space and Rocket Center, where we have a ton of people waving their flags, cheering us on tonight for this incredible launch this evening.
I love that. They totally look like cheerleaders, and they're embracing it. I love it. And yeah, this is the U.S. Space and Rocket Center. This is the visitor center over in Huntsville, Alabama. As I've said before, Marshall Space Flight Center there is super instrumental in what the Artemis program is doing. They contributed a lot to the mission, so it's nice to see everyone there. And then here is Airbus in Bremen, Germany. So Airbus is the main contractor for the European Space Agency, and together the company and ESA, they provided the European Service Module, which is an important part of the Orion spacecraft. So we have quite a bit of people there. A more reasonable time over there in Germany. It is 7 a.m. So I'm going to say Guten Morgen to them. Did I say it right? Guten Morgen to them over there in Bremen, Germany. Again, the Airbus company. All right, so let's get another check on the launch team with our Daryl Nail, who's inside there and has an update for us.
Yeah, that's right, Megan. So we are clearly in a delay now. The NASA test director, who's basically flying the ship for the launch countdown tonight, has said that we are extending the hold that we were currently in at T-minus 10 minutes and counting. And so that puts us off the 1:04 a.m. Eastern Time launch. We're now slipping indefinitely into the hold. And NASA test director Carlos Monge saying that we are currently estimating how much work needs to be done before resuming the polling that is supposed to take place 15 minutes before launch. It then goes to terminal count at T-minus 10 minutes. Now we've got an update on the tanking of the upper stage liquid hydrogen tank. Currently 95% filled. We're in topping on that tank. It is the last of 4 tanks in the Space Launch System that needed to be completely fueled up before we launch. Of course, cryogenic tanking, a complex operation that has seen some delays tonight. We had a roughly hour delay after a replenish valve on the core stage liquid hydrogen side required hands-on work by a red crew team that went out to the launch pad and tightened down some bolts on the valve and got it fixed before leaving the launch pad, and then launch team verifying that that work was complete. Now currently we're awaiting some work with the range. The 45th Space Wing, which oversees the range here, makes sure that the airspace and the ocean out over the flight path is clear, and also has the responsibility to destruct the rocket should it go off track. They have been working on some issues with their equipment and sending a flight termination signal to the rocket. There is testing that must happen with the flight termination system that was delayed by a bad Ethernet switch. Switch has been changed out, and now the range is looking to start testing their connectivity to the rocket in order to preserve that safety function that they are responsible for. So again, we are slipping now indefinitely into the launch window. We're awaiting the launch team to evaluate just how much time is required to complete the work to get this rocket ready to launch. And of course, when we have a new T0 for you, we'll report that out right away. Megan, back to you.
Daryl, thank you so much. As NASA prepares to explore the moon, here's a look at the spacesuits and tools that will help us to do that.
Watching Apollo footage of astronauts doing geology on the surface of the moon is a really great way to think about preparing for Artemis, for putting people on the lunar surface once again. We learn a lot in how they did science operations on the moon and what it's like to work on the moon. You see them doing geology, you see them taking rock samples, putting in a dry tube to take a core sample, you see them bouncing along the surface of the moon on the lunar rover that they used in Apollo 15 through 17. So it's a great way to help drive technology development for the next generation of spacesuits and geology sampling tools.
There's these facilities that help us train like we are on the lunar surface. You know, these 1.6G offload systems or putting people in the aquatic environment are great ways to train the mobility part, right? Like, what can you do and how different does it feel to be in 1.6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts had literally hundreds of hours of training in geology before they flew to the moon. It's often said that the Apollo astronauts had the
다누리
equivalent
같은
of a
경우는
master's
8월
degree
달에
in geology
발사한
by the
그
time they flew to the moon.
다누리 같은 경우는
In the intervening decades,
우리가
since Apollo,
150만
we've been
킬로미터,
training astronauts
200만
to fly to the
킬로미터를 돌아서
International
지금
Space
가잖아요.
Station because
다음 달에
when they're
이렇게
on the
가는.
ISS,
근데
they
이
spend time
우주선은
observing
직접
nature,
갑니다. 그래서
looking out the window,
달
taking
직접적인
pictures
궤도로
of what they see on the Earth's surface.
맑은 달
Now that we're
궤도로
looking
가요.
at putting astronauts
그래서
on the
아마
surface of the moon,
3일
we also take them
일주일
into
안에
the
갈
field.
거예요.
We
예전에
take
그
them
우리
to
아폴로
field sites here on
우주인이
Earth
일주일 안에
that
갔잖아요.
resemble field sites
그것이
that we expect them to see on the
몇 바퀴
moon.
돈다 세
That's
바퀴
the
네 바퀴
reason why we take them out
돌면서
into
튜브셋
places
좀
that are
당겨놓고 다시
unique,
플로이라
volcanic
해야 돼. 그
landscapes
착지를
or
하는
places
스플레이다운
that are
하는 게
analogous to
일단
the lunar
목표거든요.
surface to train them on the skill and fidelity
지금까지는
of
일단은
science
그
that you
발사가
just can't
굉장히
recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do field work in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore.
그
This is
시스템이잖아요.
a place that we've never
탈출시스템의
been
보조.
before. There's so much to be learned from getting boots on the ground and exploring a unique place
그
that
중앙
challenges
코어의
us as humans and
중앙
also
코어의
helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
단순하잖아요. 지구를 벗어나기 위해서 저렇게 아주 고생합니다. 저 오리온 우주선만 가는 게 이제 8분 15초.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us.
모든 일이 그렇지만은
solar system.
그 모든 일이 그렇지만은 진짜 결과만 보면 진짜 아무것도 아닌 일 같지만은 그걸 하기 위해서 엄청나게 노력하잖아요.
We just heard there how curiosity is just a part of us.
하나 발사하는데 4조
So, with that in mind, why don't we do some social questions? Because some people are very curious to hear what you have to say about their questions. So why don't we pull up the first question here?
뭐 카운트다운에 들어가야지 언제 발사되네요라고
What are your thoughts on the responsibilities that come with
기약
going
없는
to
또
space?
기다림을
Obviously,
또
a question for you. I am not going to space.
Yeah, the opportunity to travel to space comes with a lot of responsibility. I think for all of us, it's a huge honor to be a part of these teams, and the work we're doing is so critical in supporting scientific discovery on the ground. So on the International Space Station, we're a national laboratory. Our crew executed over 350 different scientific experiments during our 6-month mission. And so when you think about that, it's years of work to get one of these payloads or an experiment on the space station. And sometimes that's someone's life's work you're holding in your hands and executing. And so being prepared for those moments is really important, and understanding how to bring the team from the ground into solving complex problems. We take that really, really seriously. And of course, we want to share what that experience is like. Only a few people have been able to go to space. And as we commercialize space, as low Earth orbit becomes more accessible, that'll change. But still, it's only available to some of us. So we really want to share what that's like and the perspective we gain from our time up there.
It's really great to see and hear that you guys acknowledge that, right? Like that this experiment that you're holding, that you're working on for 6 months, somebody has been working on literally for years. I mean, I've talked to some scientists and they're saying, oh, this has been my life's work, 20 years of my life's work. So yeah, that was a really good question. I like that question a lot. Okay, we have another one from social media here. Astro Kayla, have you considered what you might say if you had the opportunity to be the first female to set foot on the moon's surface?
No, I have not considered that. if I was in that role, it's something I would take really seriously. I think the iconic words of Neil Armstrong, you know, one small step for man, one giant leap for mankind, are something that we all know, whether you witnessed that moment or not, or it happened before you were born. For me, I think we all have that embedded in our psyche, those important words. So I think it's something I would have to think a lot about ahead of that mission.
Yeah, that would be in the history books. That'll be something you're remembered for. Oh my gosh, I'd be so anxious delivering it, even after I've thought of what I want to say, like to actually open my mouth and say it from the surface of the moon. Wow. Yeah. That we'll have to think about that one for sure. Okay, let's see another question here. Oh, why is the spacesuit orange in color?
That's an awesome question that I wish I knew the answer to. Megan and I were actually talking about that earlier when we had Snoopy up here. It's a continuation of the same suit that we used during the shuttle era, and I was kind of hypothesizing that maybe it's to help forces if for some reason when we landed in the water we had to get out of the capsule for some reason, it would be easy to see us. But that I'm gonna have to take a phone a friend on that one, I think, to know the real answer. I'm sure somebody will be commenting on social media right now with what the real history behind the orange suit is.
I'm trying to think about it too. I'm thinking, does it have anything to do with SLS being orange because of the foam
match your
insulation?
vehicle.
Yeah,
why not?
Maybe it's that.
I don't know.
I don't know. We got stumped. That was our first one that we got stumped on. Do we have another question? All right. If you could name one of the moon's craters, what would you name it?
Oh man. What would you name it, Megan? I don't know. That's a big decision.
I thought you might say the name of your zero-G graph.
Oh, wow? Yeah, maybe. I don't know. That's a pretty big responsibility, I think, to name these geological features. And a lot of the craters on the moon already have names. So I'm sure there's some that maybe they haven't named, they're too small, or we haven't explored them yet. But a lot of them already do have names. Like we're going to be exploring the edge of Shackleton Crater as part of Artemis mission. So a lot of them are already named and mapped.
Yeah. Thanks for throwing it back on me. I was like, I don't know. Do you think like our parents or husband or fiance are now upset that we didn't say them?
I don't know. I mean, I don't think so. I think they understand.
All right.
These are big decisions.
This is. All right. Last question here for this segment at least. What will Orion do when it gets to the moon?
So for this mission, Artemis 1, it's actually going to orbit the moon and then go into a distant retrograde orbit. And so it'll get really close as 62 miles, and then go way past the moon and way deeper into space than we've ever been before. So yeah, the Orion vehicle will be checking out all of its systems. We're going to be analyzing that data from the ground, and then we're going to see that it can survive re-entry and a successful splashdown off the coast of San Diego.
Yeah, that was a good question too. Okay, well again, just keep those questions coming. You know, we are entering into this launch window, and we do have time, so we'd love to hear from you, and we'd love to try at least to answer most of your questions. So you've been hearing throughout the broadcast all the different science that returning to the moon will enable us to do. So there's actually something called the Prime 1 mining experiment, and that's going to robotically look for ice and other resources below the lunar surface.
이걸 보신 분이 더 대단하신 거예요. 왜냐면 이게 발사 그 기약이 없잖아요. 언제 발사합니다. 그게 아니고 언제쯤 발사할 건데 발사할지도 몰라요. 그런 상황이니까. 참 이거를
Thanks to data from spacecraft orbiting the moon, scientists believe that the polar regions contain water ice in the form of ice just below the surface. With the right technologies, that ice is a game-changing resource that can be mined and used to produce propellant and breathable oxygen for future explorers. Under NASA's Commercial Lunar Payload Services Initiative, the agency selected intuitive machines to fly and land Prime 1 on the moon's south pole. Prime 1 will land near the Shackleton Crater to drill into the lunar soil in an area that could contain water ice. Prime 1 is made up of two instruments, Trident, the regolith and ice drill for exploring new terrain, and M-SOLO, the mass spectrometer observing lunar operations. Trident will drill up to 3 feet into the lunar surface, extract lunar soil, and bring it up to the surface. Trident drills to its maximum depth in multiple phases, stopping at different increments. As it reaches each desired depth, it will pause and retract the drill string to deposit lunar soil on the surface for analysis. This is where M-Solo comes in. M-Solo is a commercial off-the-shelf mass spectrometer modified for spaceflight. It will evaluate the chemical elements and compounds released from the lunar soil for water and other chemical compounds. Trident will then proceed to the next specified depth and repeat the process until samples at all desired depths have been analyzed for water. If no ice is found where Prime 1 lands, NASA will still collect valuable information about drilling into the lunar soil for a future mission. NASA's Viper, the Volatiles Investigating Polar Exploration Rover, will use Prime 1 technology on a mobile robot that will navigate the moon's south pole, searching for additional resources.
그 보낸다고 이야기가 나오고 있거든요.
NASA
캐나다.
assess lunar resources
캐나다 로봇
to
하나 보낸다.
inform future Artemis missions and a robust
오늘
human presence
1시
on the moon.
11분에 발사한다 했지만 뭐 그렇죠 뭐 아직까지 결정된 거 없습니다.
So we are still awaiting a new T0 for today's launch attempt, but for more on what to expect when we launch for this first day, let's go to NASA's Dan Hewitt. He's inside our Apollo Saturn V Center at the KSC Visitor Complex.
Hey, thanks, Megan. Everybody, welcome back to the moon board. There's a lot of people here in the complex. I just heard a woohoo. People are getting in and out because we have a great
여기서는
view
이제
of launch, when
아르테미스
it's going to
미션
happen, and it's going to
경로를
happen
보여주고
today.
있는데
But that launch is just the first step
뭐,
in the
항상
Artemis
나오고
1 mission. So let's look at what's ahead for this historic first flight. As we just said, launch is step number 1. Those 4 RS-25 engines throttle up, followed shortly after by the 2 solid rocket boosters igniting, sending SLS and Orion skyward. Now on our way uphill, we'll have a number of jettison events. You'll be able to see things coming off of the SLS rocket. One of the most visual ones will be these 2 solid rocket boosters. Now they'll expend their propellant a little over 2 minutes into the flight. They will separate. We'll see them flare off onto either side, and then the core stage continues to fire. We're also going to see the launch abort system come off the top. Once you get high enough in the atmosphere, it's no longer required. You could actually do aborts using engines on Orion and its service
작동 안 하면 안 되는
작동
안 하면 안 되는 거. 그것 때문에 지금 보고 있다 지금 그 얘기 나오는데요.
The jettison motor is active. The abort and the attitude ones are not for this flight. We don't have people, so we're not flying a fully active abort system. We also have 3 fairings that are there to protect Orion, the service module and the crew module, as we're flying up through the really dense parts of the Earth's atmosphere. Next up, we'll hit core stage separation. So we've got 4 main engines. We'll hear MECO, main engine cutoff. Those engines will shut down, the core stage will separate, drop away. It's eventually going to splash down in the ocean. And that hands over the propulsion duties to this, our upper stage, the Interim Cryogenic Propulsion Stage, or ICPS. Its first job is to execute what's known as a perigee raise maneuver. So the perigee is the lowest part of your orbit. You have a perigee, that's your low part, and an apogee, that's your highest point. We're going to raise up the perigee, and that's going to actually put us in a nice circular path around the planet. And while we're there, that gives us time to check out Orion. We're flying it in space for the second time, the first time in this fully integrated stack with SLS. We'll be able to look at all of Orion's systems, make sure those solar arrays are capturing the sun's energy and turning it into electrical power for Orion's systems, make sure the communications are working, all of our guidance, navigation, and control. That is your time to make sure you have a healthy spacecraft before you do something that is going to send it to the moon. And that's next up on our list. That's the trans-lunar injection. For today's launch profile, that's going to be a firing of about 18 minutes of that single engine on the upper stage. Now that engine optimized for a vacuum, it's producing about 24,000 pounds of thrust. So it's a pretty big engine, and it's doing that because we need enough energy to be able to send our payload, Orion, beyond low Earth orbit and send it on a path to head out to the moon. Now, after that burn is complete, ICPS separates. It's going to do what's called a disposal burn. So it's going to send itself on a path from Earth around the moon and slingshot out into what's known as a heliocentric orbit. So it's going to completely leave the Earth-moon system and go into orbit around our sun. But after it separates, propulsion duties get handed over to this, the European service module. And it's got a couple of different engines that it's going to be using. And we're going to be testing those out just on day 1. We're going to do what's called the Outbound Trajectory Correction Burn 1. And we'll do a couple of these trajectory corrections as we're flying out to the moon. But that first one is that first critical test of this large engine, the orbital maneuvering system engine. That's the one that has the most thrust, generating about 6,000 pounds of force in a vacuum, and that's what's going to be doing a lot of our maneuvers, or giving us that pushing power as we do these maneuvers around the moon to enter into what's known as distant retrograde orbit, or DRO. And that's this dotted line that you see around here. Now, we call it distant basically because of the distance we're away from the moon. We're about 40,000 miles, a little bit less, off the lunar surface. And then we call it retrograde because the moon orbiting planet Earth in this direction, going in a counterclockwise fashion, we're going to be entering into a clockwise orbit around the moon, opposite retrograde. Now, to do that, we're going to get in close. We're going to dip in off the lunar surface. We're going to be about 80 statute miles off the lunar surface as we do this outbound powered flyby. Again, the major thrust coming from that orbital maneuvering system engine. After we do that, we'll do a final maneuver to actually go into that distant retrograde orbit, that DRO. Now, why DRO? Why are we not just going around the moon, coming back on like a free return trajectory, which we did on some of the Apollo missions? Well, in DRO, it's a very stable orbit. It doesn't require a lot of fuel to maintain that area around the moon. So it gives you a lot of time to really test the spacecraft. If you followed with any launch of a new spacecraft, you know there's only so much testing you can do on the ground. Once you actually put all of that hardware in space, in the environment that it's going to be operating, hundreds of thousands of miles away from Earth, you're going to learn things you didn't even realize about everything from communications, the life support systems, the thermal control, everything on a spacecraft needs to get put through its paces in this environment before we put people on board. And that's why we're heading out to DRO. Eventually, though, it's going to be time to come home, and we will do a DRO departure maneuver. This, again, firing up that orbital maneuvering system engine and others on the service module, and this is what's going to commit us from leaving the moon and heading on back towards Earth. We'll dip in once more, close off the lunar surface, slingshot, and use the lunar gravity to do this return-powered flyby, and then, similar to the way out, we can make correction burns as we kind of fine-tune our path back towards the Earth. And then it's time for re-entry. A couple of things happen before that. One of the really critical ones, spacecraft separation. We're going to detach the European service module shortly before re-entry. Its job largely done. That burns up in the Earth's atmosphere and reveals on the crew module the heat shield. I circled it earlier. This is goal number 1 of the Artemis mission. Artemis 1 mission is testing this heat shield at lunar return velocities, because when we make that trip around the moon and we come back, we are going in speeds of excess of 20,000 miles an hour. So when we slam into the Earth's atmosphere, it's going to heat that thing up to more than 5,000 degrees Fahrenheit. For the Artemis 1 profile, we're going to do what's known as a skip re-entry. So basically, you can come in too shallow and skip off the atmosphere, too narrow, and you're going to do what's known as a ballistic entry, which really heats things up. We're going to do kind of a mix where we're going to skip once off the atmosphere, and that we're still going to get the heat that helps to reduce some of the G loads on the crew. Once you're through that, you get to parachute deploy. There's 11 parachutes in total that are going to slow Orion down before it splashes down. We're going to be going from 20,000 miles an hour to about 300 miles an hour before those parachutes deploy, and then they do a final job of getting it in the water in the South Pacific. We've got these big orange balloons. That's an uprighting system, so even if Orion landed in the water upside down, those can inflate, and they put us back upright into what's known as stable 1. That's where you want your spacecraft to be, nice and upright in the water, especially if you're an astronaut in there floating. Now, we also have a large U.S. Navy ship with a big bay that's going to basically come up and swallow Orion into its deck, and you've got a couple of other assets in the area to help recover hardware, the forward bay cover, parachutes, things like that. But that's scheduled to happen 26 days after a launch today. So that's 26 days
45분 이전에는 발사하지 않을까
around the moon to a splashdown in the Pacific, and that will be the first mission in the Artemis program, the farthest we've ever sent a human-rated spacecraft in history. and just the first step before we put people on board. So that's a look at everything still to come. We're counting down to that launch. I'll send it back over to Megan and the team at the host desk, guys.
A very comprehensive look at that. Thank you so much, Dan. If you're just joining us, welcome to Kennedy Space Center and our live coverage of Artemis 1, an uncrewed flight test that will return us to the moon in nearly 50 years. But you know, some might ask, why the moon? Well, here's why.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet.
지금 여러 가지 보여주고 있죠. 시간
just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science. It holds opportunities for us to make discoveries about our home planet, about our sun, and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from.
5시간 차이죠, 5시간.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it into drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts. And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Throughout this launch broadcast, our NASA's Leah Martin has been introducing us to people over at the Kennedy Space Center Visitor Complex who have come out for hopefully the maiden voyage of Artemis 1. People from near and far, young and old, just really excited to hopefully see this historic flight. So now she's joined by somebody else who has a really interesting story. Leah, tell us about it.
Megan, I think one of the most exciting things about being here tonight is being with people who are like-minded, who have such a strong tie to the history of our nation's space program and their love of spaceflight. And I actually struck up an amazing conversation with Scott here, and you were telling me about the special tie that you have to tonight's launch as well.
Oh yeah, I literally grew up with NASA. My father went to work with the NACA before NASA, went to work for Dr. von Braun, followed him over to Marshall Space Flight Center, and became, when it became NASA, he worked on the Jupiter C, Redstone, Saturn 1, Saturn 5, and then because of that, he brought me here to see Apollo 11 launch. So that was my first launch. I was 5 years old. I loved it. Still remember the sound. That's about all. And then years later, through my flying career, I was able to bring my sons back with my friends that flew the shuttle, and they saw 5 launches and 4 landings. But basically, I wanted to be here. I was here for the first moon launch, the last moon launch back when Uncle Gene Cernan, our family friend, went to Apollo 17. So I wanted to be here for this because it's kind of in our family, in our blood, and hopefully I'll be around for the next one when we go and land again. So that's
incredible. So you have NASA actually in your DNA, grew up with the program.
Yeah. I knew most of the German scientists. The kids sat in our lap, Dr. Ernst Stirlinger, and my father flew with von Braun because he was a general aviation pilot as well. So they get off work and fly, and they were in Life magazine together, National Geographic. So it was fun. I literally got to knew Al Shepard, all the Mercury, Gemini, Apollo guys, and it was an honor. I would have loved to have been an astronaut, but I went a different route, and but I can still come here and see them.
We can, and we're so grateful, so thrilled to see you here tonight, and so excited that you will be able to actually compare the last launch and the sound of the last one with the one tonight. It's absolutely going to rock the sky.
I want it to be even louder. I want to feel it. Yeah.
Thanks so much for joining us tonight. It's been an honor to meet you, and Megan, we're going back to you.
Leah, thank you so much for sharing that. That was such a fun story. Here we are now at Space Center Houston. This is a live look inside of the visitor center there. Lots of people hoping to see the launch today. I love this guy in the front with his NASA shirt representing. And again, just seeing children and young and old, just all these people who feel captivated and are excited about our next giant leap into deep space. So glad to have them here. Oh my gosh, I love this.
Yeah, the team in Marshall and Huntsville there is always ready for their shot, waving their flags. They're super pumped. That's the home to the SLS program office, so they have a dog in the fight tonight, seeing Artemis launch for the first time.
Is that an inflatable astronaut in the center? Do you see that? I think somebody is dressed up as an astronaut.
Look at that.
Yeah,
they're
representing.
Ready to go.
I love this. Yeah, I'm so glad that they're there. Again, these visitor centers are closed to the public, but the people there decided to hold a watch party.
Oh,
and
look,
that's
our friends
exciting
in
to see.
Germany are ready for us this time. They anticipated the delay. They look pumped. Ready to go.
So these are employees of Airbus. Airbus is the main contractor for the European Space Agency, and together they provided the European service module for the Orion spacecraft. So really, we should be applauding them. They shouldn't be applauding. Thank you so much, guys, for your contribution to the program. And
이거 발사 생중할 때도 저 난이를
Orion and SLS launch. Okay, so now let's head back over to Daryl Nail over with the launch team so we can hear any updates about a new T0.
Yeah, Megan, thank you. And a clearer picture is starting to emerge as the launch team now reports out that they only have a few minutes left of work to do before they're ready to pick up polling. And we're also hearing that some of that polling, which kicks off with the mission management team, is also now just about 3.5 minutes away. Now, we are currently still in that hold. But the launch team, NASA's test director, is continuing to move the team forward. We've wrapped up work on the upper stage and the lower stage. You're looking now live inside firing room 1. Our launch director Charlie Blackwell Thompson.
세레스 그 중국 그
overseeing
로켓은
her launch
조금씩
team.
발사했나 지금?
We've had a
발사를
number of delays
하는데
that have put us off the T0,
발사했겠다.
but we are starting to track to a T0
아니겠어요? 아 여긴 아니고.
close to
3분 남았네
around
저기서는.
a quarter till, top of the
네.
hour.
지금 뭐
But we do
어디 저기 있는 저기 미션 컨트롤인가요?
need to have some polling that takes place. I'm pausing now
롱
because
포유라
I'm
해가지고
listening in to
그
the teams
미션명이
as they
요즘 중국도
communicate.
굉장히 좀 신경을 쓰는 것 같아요 이런 것들.
In this launch window, which we're currently 26 minutes into, and it's 2 hours long, it runs until 3:04 a.m. Eastern Time. We have what's called 40 cutouts. And in those cutouts, they range from about a second to about a minute. These are times where they can't launch. These cutouts must be accounted for when determining a new T0. The upper stage of the rocket, which was the last to get ready and configured, just recently the team cycled the liquid hydrogen valves, which is required, and they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done.
지금
We are now a minute and a half away from the pole of the mission management team, which is several minutes before T-minus 15 minutes.
지금
When that pole starts, we'll get a clearer picture of our T0.
그 폴링 그 발사 폴링이 지금 얼마 남지 않았다 그 얘기 나오고요. 미션 관리자 투표를 하려고 그래요. 그래서 이게 발사가 가능한지 안 한지 그거를 아주 각 미션 컨트롤 관리자들이 이제 그 확정 짓는 거죠. 일단 그게 얼마 남지 않았다고 하는데.
And what this means is that the entire launch team is now on one channel, and all future communication will happen there. Whereas there are many channels. Now they reduce it down to one.
폴링 시작했네요. Awaiting new T0 지금 기다리고 있다.
I'm sorry, Jeff Spalding's on. They swapped out.
지금 나사에 따르면은 발사를 위한 추가 작업 확인은 거의 완료됐다 합니다. 그래서 고냐, 노고냐 이거를 이제 판단한다고 판단할 거로
얘기했네요. Getting ready
요
to pick up with a poll to determine readiness for launch.
발사에 큰 문제는 없다고 합니다 지금. 아마 지금 보통 그 ULA 같은 경우는 그 발사 이런 거 컨트롤 고를 이게 그 공개적으로 이야기해 주거든요. 근데 이건 안 해준 것 같아요. 발사를 그 안에서 결정하고 이제 발표를 할 것 같아요.
Okay, NASA Test Director Jeff Spalding getting ready to conduct the readiness poll, so we are getting close.
거의 끝났대요. 발사 그 투표.
We're going to pull up the audio now.
네,
so that you can listen in.
긍정적으로 보인다. 발사 지금 투표는 끝났고
Please go and rock.
나오죠 지금?
Rockets go. All right, copy all. And launch director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the launch director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS, Orion, and EGS CSOs have no constraints and are go for launch.
거의
Copy, John. Thank you.
네,
Range weather.
굉장히 긍정적으로 나오고
Weather
있습니다.
has no constraints and weather is go for launch.
Go for launch.
Copy LWO and Mission Manager. And Mission Manager, Launch Director.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis 1.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, launch director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Copy, launch director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD.
CVSC here.
Initiate recording of Orion cameras at this time.
In work.
NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch Director.
Early.
지금 아직 타이머는 안 나왔는데 지금 10분 후에 발사가 될 것 같다고 합니다 지금.
The poll that you heard was the NASA test director's poll, and
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
Okay.
T-minus 10 minutes and counting.
We are T-minus 10 minutes away from liftoff of Artemis 1. As you can see, the clock is now moving. Let's put that up. T-minus 9 minutes and 47 seconds. The L-minus 15.
네, 자, 발사 카운트다운 시작했습니다.
47, 44 is the new liftoff time.
Affirm.
Okay.
Oh, 1:47:44, 1:47 a.m. Eastern Time and 44 seconds.
10분에 발사. 자, 10분으로 발사가 결정이 됐어요. 네. 아, 쉽지 않습니다. 드디어.
Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the ground launch sequencer, a computer and software that is doing all of the commanding and monitoring.
자, 드디어 물론 이게 발사 카운트다운이 항상 그렇지만은 그 발사 1초라도 남아 있어도 이 문제 바로 생기면은 바로 시도가 가능해요.
Alex Pandalos. As well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction.
자, 몇 분 지금 8분
T-minus 8
남았습니다.
minutes and counting. The GLS is performing up to 100 commands per second, including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers. Purging the aft skirt booster with high flow nitrogen. Clear out any hydrogen gas that may be there. You can see the crew access arm is already retracted. When there is crew during Artemis 2, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. Want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds.
자, 6분 20초 남았습니다.
Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization. Fire Room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion Ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
자, 제가 얘기 드렸지만은 발사하고 나서 1분 10초에 매치큐에 돌아가고요.
The flight termination system is now armed.
사단판에서 아마 같이
Coming up
보여줄
at
거예요.
4 minutes and 40 seconds, a big moment. This is
자,
where the
4분
RS-25
남았네요.
engines
4분 40초.
and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds.
4분 10초를 향해 가고
Up
있습니다.
next, GLS fires up the KPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit Start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage. At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
자, 이제 3분 남았어요.
Go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Coming up in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal. And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. Altogether with the boosters, 8.8 million pounds of thrust.
Let's go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS, go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
올라갑니다.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing under the ML. And here we go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
아, 이걸로 테스트해야겠다. 자, 발사됐고요.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
자, 1분 20초 때 지금 보고 있습니다, 지금.
Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour.
17대를 가고 있습니다, 지금. 이미 올라가고 있고요.
Standing by for solid rocket booster jettison and shortly thereafter.
네, 발사가 됐습니다. 지금 2분 때면은 아마 지금 사이드 부스터 지금 아마
confirmation that the solid rocket boosters have separated these 177-foot boosters. Now the core stage continues to power the flight of Orion. All 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange.
발사가 됐고요.
2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated.
아마 지금 발사 지금 2분 때라면 발사 탈출 시스템
And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members.
지금 2분 때 지금 그렇죠. 2분 서브 고체 연료 부스터는 떨어 나갔고.
We just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
야, 드디어 올라갑니다, 그래도.
We're 4 minutes and 16 seconds into the flight of Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good.
예, 아주 지금 상태가 좋다. 지금 나오고 있죠.
Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight.
야, 드디어 갑니다.
5 minutes, 42 seconds into the mission, we are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center. Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
야, 드디어 올라가네요. 드디어 올라갑니다.
About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire maximum thrust. Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down.
지금 이제 8분 때문에 지금 메인 엔진
30 seconds now until
컷오프하고
core stage main engine cut off. All 4 engines continue to throttle down.
세퍼레이션, 즉 메인 중앙 코어가 이제 분리가 될 거예요.
Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour. Continuing to hear good calls here in Mission Control Houston. We're standing by for core stage main engine cutoff.
리코가 안 되나요? 다리 보입니다.
And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit.
지금 다리를 같이 보여주고
The flight
있어요.
dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it.
Well, I don't think we're Megan and Kayla here, but they do have friends at Kennedy Space Center. Let's see if we can't get Hayden and Philip back into commentary.
That was
Is everybody still here?
I am.
That was nuts.
Admittedly a mess, but so yeah, folks. Orion is on its way to the moon. Artemis 1 is on its way to the moon, as you saw there, SLS, the Space Launch System, beautifully and successfully lifted off of Launch Complex 39B at the Kennedy Space Center in Florida. It appeared to be a clean ascent. SRB burnout and separation was beautiful. It looked very clean. And as we saw there, all indications show that separation of the core stage from the interim cryogenic propulsion stage were good. So.
Let's see if we can't check in, Hagen, with the folks out in the field.
Yeah.
I know we heard
I'm
from
ready
Jack
to hear Chris G.
briefly. I think Chris G is going to be coming back in. I want to
Chris
hear.
G is here. He's getting on comms. He is. I think he's composing himself. That was. The sound was almost scary for a moment there. It went. We're on our way to the moon. Congratulations to NASA. I'm working on a video right now. The emotions at the press site were utterly insane. I mean, people were expressing happiness and elation at launch, like I've never heard or felt at any other launch that I've ever attended or witnessed. I'm just kind of wow. What a,
I think we're all in a state of shock right now.
What a vehicle! What a launch! How great was that?
Chris, I want to hear from you. You've been waiting for this day for over a decade. How was it?
Everything I wanted it to be. It was everything I wanted it to be. Oh my gosh, when the boosters lit, that was just... Oh my gosh, when the boosters lit and they did their overpressure thing on the back end, and just... The sound, the light, I mean, it was everything I remembered and more, and it was an incredible start to this 2016 mission, and no one can say that SLS doesn't work. SLS works, and SLS is the most powerful rocket we have that has ever flown, and yes! Yes, Orange Rocket, good, yes, oh my gosh. That's my initial reaction.
Okay. Do we have Philip back with us? I'm sure he is just as elated.
How did I get muted? I was, if I've been muted the whole time, I apologize. But I mean, I would say to me, we waited a long time. It took them a while to get everything to line up, but that's why they waited this long, is because they wanted it to be a clean, boring launch. And this is only the first half of it, but these are the systems that they've been working with for a while. The boosters and the core stage seem to have worked perfectly. And so this is what they wanted. They wanted a clean launch. This is, it's a flight test. It's only one launch, but they wanted to, sort of
이번에도
wanted to
연기될 줄
launch
알았는데
in the middle
잘 날아가고 있어요.
of their in the sweet spot to give it the best chance of success. And at least, we're just talking about the core stage and the boosters, but that's the base of the SLS, and they both performed, almost flawlessly. It certainly, we didn't hear of any issues going uphill at all.
Yeah, and the other thing I'll say, because this is the emotional part for me. My generation has now seen a human-rated vehicle launch to the moon and launch to another planet, another celestial body. That is the emotional moment. Like, for so many people who remember Apollo and saw it with their own eyes, and to those of us who weren't here yet, this was an incredible moment to experience. I mean, like you were saying earlier, Sawyer, the combination of Apollo 4 and Apollo 8 in a very interesting way for what they are doing here. But that's the emotion of it. We've seen a moon rocket launch, and I'm going to let Sawyer. But I mean, we have seen a moon rocket launch.
Yeah, Chris, I think we actually have some control center audio here. Let's see if we can't listen in on the control room.
Can you guys hear me?
Oh,
there we go.
지금 그 태양전지판 전개가 성공했답니다.
Well, for once, I might be speechless. So you guys know I have talked a lot about appreciating the moment that you're in. And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment. It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first. Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis. The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. What a beautiful view it is. So congratulations. So we got a couple of traditions here in launch control. And the first one is when you're in the position for the first time, you get a tie cutting. And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs. If they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
That's Bob Seek, the old shuttle launch director.
And it's Mike Leinbach,
and Mike Leinbach. Yeah.
They're going to do the tie cutting.
Okay, that makes me cry again.
You're not alone right now, Chris. Oh my God.
Nice. That's awesome.
This is Charlie Blackwell Thompson, Artemis 1 launch director. She just got her tie cut. That is a tradition here at NASA. We just got to hear her talk to the team, and one thing that really stuck out to me.
어떤 간에 축하합니다. 드디어 성공했어요. 그리고 이제
Alright, sounds like they're going to go back into talking about things. But again, Chris and Sawyer were sort of hopping in. Philip talking about the tie cutting ceremony there. Wow.
There, say it does.
Well,
it is my very favorite shot. Yeah, we were real quick there. It was the very favorite shot on launch day. It is the empty mobile launcher. Does not have an orange rocket anymore. Orange rocket's payload, I guess, is on its way to the moon.
Yeah,
thanks for bringing that shot up there. Go ahead, Philip.
I just want to remind, we just need to keep in mind, this getting as far as they've got is a big accomplishment, but we're getting pretty close here to when they were going to deploy Orion solar arrays, and so I know there's that milestone. And then we have a little bit more time before the for the perigee raise maneuver, which is about 51 minutes after liftoff. But we do want to hear. Hopefully, we'll get an update here. It looks like over on. Oh, here we go. Maybe we'll get an update here because we are waiting for solar array deploy on Orion.
Yeah, while they look for that confirmation on solar array deployment, though, to reiterate what the team was able to do today, they launched the SLS rocket.
일단 오늘 여기까지 저는 여기 하기도 하겠습니다. 그리고 여기까지 지금 봐주신 모든 분들께 감사드리고 네, 다음에 또 다음 발사로 찾아뵙도록 하겠습니다. 네, 감사합니다.
And launched it. Awesome.
That is now the most powerful rocket in existence at the